This is the lecture of switchgear and protection. In this lecture, we will study the percentage differential protection. In last lecture, we studied simple differential protection. In this lecture, we will study the percentage differential protection. Here you can see that this is the figure of percentage differential protection. This is coil or equipment which must be protected by us. Okay, so in previous lecture we represent one equipment here coil is available. Here you can also put the equipment, which equipment you have to protect using percentage differential protection. Okay, on besides of that equipment, CT1 and CT2 are available. CT1 is connected here, CT2 secondary is connected here. Okay, here you can see that the main difference between simple differential protection and percentage differential protection is this coil. This is the operating coil. Okay, this coil is known as operating coil. This is the restraining coil. It is represent here. This coil represent as operating coil. This coil, which is divided into two parts, is known as restraining coil. Now the main difference between simple and percentage differential protection is restraining coil. You know that in simple differential protection only operating coil is available, no restraining coil is available. But to overcome disadvantages of simple differential protection, we will use the restraining coil. So it is known as percentage differential protection. Okay. Now this is the figure. In normal or healthy condition, you can see that the current flowing here is same of inward and outward. Okay, the current flowing inward the coil is same as outward the coil. That's why this is the system current I. It is same in both way. Okay, now due to this current, the I1 current will produce in CT1 secondary. Due to same current in CT2, I2 will produce into the CT secondary. Okay, I2 will produce into the CT2 secondary. You know that in normal condition this I is same, that's why I1 and I2 both will same. Okay, I1 and I2 both will same. Here not I2, only I1 is I is available. Why? Because this current is same. Here also I is available. Okay, so same supply current is, if CT1 and CT2 has the same ratio, then I1 and I2 both will same in normal condition, same as simple differential protection. Now you know that according to this direction I1 will produce, according to this direction I2 will produce. Okay, if you are extending the direction of I1 and I2, then you can see that I1 will go towards the downward, I2 will go towards the upward. So in normal condition, the net current flowing from operating coil is given by I1 minus I2. Okay, in normal condition, net current flowing from operating coil is I1 minus I2. Now the change is restraining coil. Okay, now first of all we will study the disadvantage of simple differential protection. You know that in simple differential protection it will operate for heavy external short circuit condition. Okay, it will operate for heavy short circuit condition. Why? Because in normal condition this CT1 and CT2 both are not identical. It means that in normal condition also the difference between I1 minus I2 is not 0. For ideal condition it must be become 0 for healthy condition, but in practical situation it will not become a 0. That's why when external heavy short circuit fault occurs, then due to increment in this current, the I1 and I2 difference will also increase, and that's why simple differential protection will operate for external short circuit condition. Now that must be cured by percentage differential relay. Here you can see that mechanism or working principle is same. Why? In normal condition both have a different direction, that's why in normal condition this must be become 0, and for external or fault occurs between the protected zone, this will change its direction and this will become I1 plus I2, so net current will flow for internal fault and this relay will operate. But now we will take the situation for external heavy short circuit condition. Why? Because external heavy short circuit condition create the problem in simple differential protection, and it will overcome using this retaining coil. Okay, let's say in normal condition I1 minus I2 must be 0. In normal condition, if this strategy is ideal, then I1 minus I2 will become 0, but this strategy is not ideal, that's why it will not become 0. So what will happen? Here you can see that I1 minus I2 will not become 0. That's why some operating torque is available here in normal condition also. Or let's say we will take the heavy external fault condition. In heavy external fault condition means fault occur outside the protected zone. So this relay must not operate for external fault. Let's say it will happen due to this fault, the very high amount of current will flow. That's why I1 minus I2 difference will also increase, and that's why for external fault this relay will operate. Okay, now we will take the percentage differential protection. Now you know that due to heavy external short circuit condition, I1 minus I2 difference will increase. Why? Because due to heavy fault condition, I will increase. Due to that supply current, I1 and I2 will also increase. Okay, and due to increment in I1 and I2, you can see that here I1 and I2 will flow from retaining coil also. એટલે કે I1 અને I2 retaining coil માંથી flow થાય છે. Okay, retaining coil will produce retaining torque, operating coil will produce operating torque. Okay, when relay will operate, then operating torque is higher than retaining torque. When in normal condition, always retaining torque is higher than operating torque. આપણે આગળ ચેપ્ટરમાં સ્ટડી કરી ગયા છે કે જ્યારે રિલે ઓપરેટ થાય ત્યારે ઓપરેટિંગ ટોર્ક હોય એ રિસ્ટ્રેનિંગ ટોર્ક કરતાં હાઈ થઈ જાય. ઓકે, નોર્મલ કન્ડિશનમાં રિસ્ટ્રેનિંગ ટોર્ક હોય એ ઓપરેટિંગ ટોર્ક કરતાં હાઈ હશે. ઓકે, સો for external short circuit condition with increment in difference of I1 minus I2, this I1 and I2 will also increase. That's why MMF produced by retaining coil is given by I1 plus I2 into n by 2. Here I1 plus I2 into n by 2. That is the torque produced by retaining coil. Okay, why? Because I1 plus I2 into n by 2. That is the torque produced by retaining coil. And the torque produced by operating coil is given by I1 minus I2 into the number of turns of operating coil. Okay, so obviously you know that for external short circuit condition, this is the subtraction, this is the addition. That's why in normal condition retaining torque will become greater than operating torque. Okay, in external fault condition retaining torque હશે હંમેશા operating torque કરતાં higher થશે. એટલે એનો મિનિંગ એવો થાય કે I1 minus I2 અહીંયા 0 નહીં હોય તો બી retaining torque કરતાં operating torque reduce એટલે કે less than થશે. So our relay will not operate for external fault condition. Okay, so this is the disadvantage of simple differential relay. Okay, will overcome by percentage differential relay. As I said you, this is the note. Under heavy external fault condition, I1 minus I2 must be 0 for ideality, but in practical it will not become 0. So it is chance to operate the relay under the external fault condition. External means the fault is available outside the protected zone. Then what will happen? But the retaining torque will also produce. Okay, with increment in main supply current due to the external fault, I1 and I2 will also increase. That's why due to increment in I1 and I2, the retaining torque will also increase. So that's why retaining torque will become greater than operating torque, and that's why relay will not operate for external fault condition. Okay, this is the figure of same percentage differential relay for internal fault. Okay, so this is the internal fault. Internal fault means it is come into the protected zone of differential protection. That's why for this fault your relay must be operated. You know that if fault occurs here, then direction of I1 is like this, direction of I2 like this. Okay, here same current I flow, okay, inward, and here the direction of I is changed. Okay, it will become inward to the coil. Why? Due to the availability of fault. Now due to this I1 will produce, due to this I2 will produce. But now in this condition the direction of I2 will change, so it will flow like this. The direction of I1 will same as earlier. So now in for fault occurs in protected zone, the current flowing from the operating coil is given by I1 plus I2. Okay, same, this retaining coil will produce the retaining torque. Here you have to note that for internal fault condition the relay must operate. Okay, but in faulty condition also the retaining coil will produce the retaining torque, it will not become zero. But for internal fault this torque is proportional to I1 plus I2 into n by 2, and this torque is proportional to I1 plus I2. So you know that the always in faulty condition the retaining torque will not become zero, but in for fault available in internal side the operating torque will become greater than retaining torque. Okay, retaining torque zero no થાય, but due to the addition of I1 and I2 now the operating torque will become greater than retaining torque. That's why this relay will operate. Okay, and relay will operate only when the operating torque will become greater than the retaining torque. So that's why this protection strategy provides the protection for internal fault and neglect the external fault. Okay, this is the same notes under normal condition, okay, equal to 0. Under faulty condition it will not become 0. That's why internal fault operating torque will become greater than retaining torque, so relay will operate and provide trip signal to circuit breaker. So this is the main strategy of percentage differential protection. Okay, this lecture is completed.